Hey, this is Don from Padlock Technologies again with another video. This is going to be based on previous videos that I did on MPLS inter AS L3 VPNs. Today we're going to be doing option A. If you don't know what option A is, stop watching this video. I'm going to put a card somewhere up here to the theory of option A. You need to watch that first before you watch this video because this is more of the configuration side. And if you don't really get the theory of option A, a bunch of configurations will confuse you of why I'm doing what I'm doing. But this is for my folks that are usually going to the CCIE service provider lane, but it still has the normal CCIE enterprise or enterprise infrastructure. I think that's what it's called. Or EI, I believe that's what it's called. It still has concepts of that in there because you still need to know about. In this example, it's going to be OSPF, and then I threw the service provider stuff with ISIS, but it doesn't really matter because CCIE EI or enterprise infrastructure and service provider, they overlap on a certain points and then they have their specific track technologies, right? And this is mainly in the service provider track, but MPLS is still in IE or EI, sorry, enterprise infrastructure. So you definitely need to know that. I put ISIS in there because I don't really care what track you're going to. You need to learn ISIS. I know a lot of people say, oh, you don't need to learn that until you move to service provider. But if you're doing certain things, case in point, if you're dealing with ACI, if you're dealing with SDA, if you're dealing with those type of technologies, they have ISIS running underneath the hood. So if you at least learn how ISIS runs, then you're okay, right? You'll probably not see that or have to configure that in the enterprise environment, but knowing it is just going to further you as a network engineer. So what do we have here from a layout standpoint? So we have two AS, different ASN numbers. So we have ASN 65001. The bottom we have 65002. OSPF aerial. OSPF is going to be the IGP for the underlay of 65002. And then ISIS, just normal regular ISIS, all level two, no level one and twos. You don't really need that in this example, but all level two for ASN 65001. Then we have our independent ASNs under here. So we have 65003 all the way to 65008. Now, what you're going to see is customer A, B, and C. What we're going to do is we are going to do a inter AS L3 VPN, meaning we're going to have an L3 VPN all the way through from one AS to another AS. Think of these big ASs in the middle are 65001 and 2. Think of them as a service provider. And what we're going to do is we're pretty much going to have, this is a customer C right now. It says leak routes, but I haven't did any route leaking yet. We're going to have our customer C routes come from this router 11, router 12, router 13. I think router 12 is customer B, router 13 is customer A, and we're going to be able to have a L3 VPN go all the way. So traffic is going to go all the way from one AS to another AS until its respective peering our partner down here. Um, and we're going to be able to, I'm going to do a trace route so you can see the actual like labeling and position are being pushing the label, swapping the label, popping the label. Now, the one thing in this, I did a little special thing here. You're probably never going to see this in real world option A, but I'm running OSPF between these two PECEs. Now, why do I call them PECEs? Because depending on the direction, it's either going to be a CE or a PE. So from 4 to 5, 4 is a CE to 5, but a PE to 5, right? So depending on what direction you're going, it's going to treat it as a CE when it's going in one direction and the other one's going to be a PE. Now, the reason why I did OSPF is because I wanted to show you a feature that you need to do with this specific setup for OSPF because the VRFs are going to exist on these routers. And when you're doing MPLS or you're doing something with a VRF, OSPF will not share those routes if there's VRFs on here, right? So you have to enable this capability called Capability VRF Lite. And that's only when you have VRFs technically on these ASBRs and you're not using BGP, right? You're using OSPF, right? So there's an OSPF adjacency here. And without that capability VRF lights, I wouldn't be able to share those routes into the AS and see it pop out on the other side. So I wanted to show you that because most people, when they do this, they do BGP between the ASBRs, and the next thing you know, yeah, that's all good and well. You probably see that in the real world, but when they do, your CCIE studies, they may throw this at you, and if you don't know that capability, then you're going to be stuck. And trust me, I've been burned on this one time in the real world because somebody actually did OSPF as a PECE protocol and was running VRS on the CE. As soon as I said we did that, I got burned for an hour messing around with it, and I was like, "Oh, I forgot. I totally had a brain fart and forgot that. Oh yeah, you need to enable this under the VRF." So wasted an hour of troubleshooting time because I just had a brain fart of it. But now let's take a look at it. So mainly, what I'm going to be showing you here is from an OSPF perspective. We're running, point to point. So when we show the OSPF neighbors, you should see we're going to router 6. And if we look at the OSPF database, we should only see route type where our, let's say, LSA 1s. Yeah, LSA 1, because you're going to see the router LSAs because I'm doing point to point. So there's no need for a network LSA. If you don't know anything about LSAs, I'll probably put another card in this video, if not, about the OSPF LSA types 1 through 10. So if I go to show OSPF database, as you can see, all router LSAs are type 1 LSAs, right? No twos because we're doing all point to points. From a routing perspective, we can just show IP route. And here's what we see here from a show IP route, but that's going to show everything, including the connected and local routes. But if we do OSPF, we know how to get to the ABR, and we know how to get to the route reflector. Now, from a BGP perspective, if we show the BGP configuration, basic BGP configurations here, and we'll start from the top. So we have our router BGP. We have some peer sessions templates that I'm using. I like to use peer session templates because I can just keep reusing the template instead of having to type individual commands all the time. We have a template for customer C, customer B, customer A, and then we have our neighborship statements down here. We have our neighborship for just the VPN v4 table, which is here, VPN v4. I don't know why that just did that, but VPN v4. And then we have our individual VRF statements, right? Individual VRF statements. So when we look at the BGP VPN v4 unicast all, as you can see, we have all these routes in the VPN v4 table. You see some for customer A, B, and C because we are basically doing our route targets, the route target both. So my import and export targets are the same. So as long as we matching that, whatever I import from the VPN v4 table will be in its respective VRF and vice versa. So that's what we have right here. So if I show IP route VRF cus A, as you can see, VRF cus A, only thing I'm doing is advertising the loopbacks from the CE side. So I should see 255, 255.13, which is there. And then 16, which is down here, right? So that verifies that 13 and 16 can see each other. They know the routes, right? So if I go to 16 down here, I should see a 255, 255, 16. I mean, 255, 10, 255, 255, 13. Sorry about that. So show IP route. And I'm probably going to see that OSPF link as well. So yeah, so here's the OSPF link. That's between 4 and 5. I'll show you that. And then here's the 13 here. So if we try to ping it, versus from the loopback, as we can see, we have reachability. So we have a inter AS L3 VPN using option A. So what's the difference between option A again? Remember with that card that I showed you in the beginning, or I said I was going to put in the beginning, you can look at that, but I'll give you a brief synopsis of option A. So basically what's going to happen is it will put a label on here. It's going to swap the label. Technically, it's going to pop the label here. This is going to be the pin ultimate router here, right? So the PHP process is going to happen on this router or router 6. Once it pops the label off, it'll be a VPN label. Once it gets to this VPN label, it pops the VPN label off. And between router 5 and 4, it's IP. It's no labeling whatsoever. It's just a straight IP packet. That's the difference with option A, right? Compared to B, C, and D. Then when it gets to 4, it puts another label on for this AS. Then it gets to this router 2. This is another PHP process because this is the penultimate router. And this is technically the ultimate router if you want to know vernacular here. Then when it pops off that other label, you get the VPN label on router 1, pops off the VPN label. Obviously, the next hop is already in the VPN label, so it doesn't have to do a route lookup. And then it'll go to router 13. That's technically what's going to happen. Now, because I did OSPF, I do want to show you the intricate parts of OSPF. As you can see, you still need to know your normal CCIE enterprise infrastructure stuff because MPLS is MPLS. You know how to do basic MPLS, then you know how to at least set up the 2 different ASNs. You just need to know now the service provider part, which is the inter-AS VPNs and stuff like that, right? So if we go to router 4, what we're going to look at here specifically is a couple of things. So if we go to, we're going to look at show run interface G1. I don't know why I put that extra dot there. So as you can see, we are using, obviously when you do sub interfaces, you have to do an encapsulation, and it's going to be, .1Q, right? .1Q encapsulation. We have it's in the VRF CUS A, IP, OSPF point to point, and then we have our IP address. Now, if we look at the routing for that, here's the routing. Now, this is super lazy, by the way, and this is just an example for this lab, but I would never do the network 000 or quad 0, 255, 255, 255, area 0. I would never do that in real life, in real production, right? That is the super lazy way to do it, and you can end up activating OSPF on links that you don't want to do that on. So I would definitely do not do this in production, right? But what I want to draw to your attention is this capabilities VRF Lite. Because we have VRFs and we're doing the adjacency under a VRF, when that route comes, when it gets to the CE, if if you have a VRF, it just drops the route, totally disregards the route. Like it won't advertise it, right? You have to put the capabilities VRF to stop it from being discarded, right? And that's very important in this situation. Now, if you were doing just BGP between the two, you wouldn't really have to worry about this, right? So once that's there, and if you want to see the adjacencies here, I think it's show IP OSPF. I think it's VRF CUS A neighbors. I think it's VRF CUS A. I keep forgetting what that command is. I think it's VRF. Yes, there it is. Because this is what happens when you've been doing a lot of like iOS XR stuff. A lot of the commands has changed. Cisco, y'all need to just make one operating system and leave it at that. We don't need a new operating system every time you come up with something. Just add more features to an existing operating system. It's Cuse, is it? Nah, it's not that. Let's see here. See, now this is going to get on my nerves. Where's that command at? All right, I'll just do neighbors for now. But this is like that in iOS XR, you can actually do it specifically for the neighbor, but I can't remember if you can do it on iOS, just normal iOS. So as you can see, here's my three neighborships here, and they're in their uh, VRF table. And as you can see, this is point to point because you don't see a DR, BDR election, so you don't really have to worry about that. And then from a routing perspective, we do show IP route VRF I did cuss A, right? So we do cuss A, and as you can see, we have that BGP route coming in from 13, which is going to come from router 1. And then we have this E2 route, because remember I told you by default it's an E2 route unless you make it E1 route. That 16 is coming in because it's being redistributed from BGP into OSPF, and then it's getting advertised to router 4 because of that capabilities VRF Lite command. Right, so now we're going to run a trace route from, I'll do it from 13 this time. And then what you're going to see is the label. Let me expand this a lot bigger. What you're going to see is the label on router 1. You're going to see the transport label and then the service label, which is transport label. Think of it as the bus. Service label is our VPN label, but it's also called the service label. Think of that as the passenger and then the data, right? So we go up in here. Shall be real. I can do BGP if I want it. And then we're going to trace 16, source it from loopback 0. And we're just going to watch it. So you're going to see a label. Now, I will tell you with router 4, I formed an adjacency before I did the label range command. So you may see different label types. I like to set the label range so I know what router it's on. So when I see the label, I can tell it's router 1, router 2, router 4. But we may see like a 16 because I did restart the process. So it may be 400, right? So it is 400. So you see that 200, that's the transport label, which goes to router 2. And then 403 is the service label. 200 got popped off. So now it is 403, which is the VPN label. And you see it says AS 65001. Now you see now that got popped off, and that's now a basic IP packet. Now we're going to see the label from 65002 get added on. Now you can see it's 601.707. 707 is the VPN service label. 601 is just the transport label that's going to get popped off, and then you're going to see just the VPN service label. And that will get popped off because you're going to see PHP happen, and then it'll be a normal IP packet, and then it will stop, and there we go. So that is what you're going to see with option A. When you get to the ASBRs, it will turn into a normal IP packet, which happened right here, right? So that's when that's when the VPN label got popped off or service label got popped off, and then it turns to a normal IP packet. And then when it got to the other side, which is ISR 4, ISR 5, imposition happened, or pushing a label on top of it happened. Then it got technically got swapped a little bit well, yeah, I mean it got pushed. Then it popped off since it's not really a swapping per se because it's only 3 routers, and it's right next to the router. The PHP happened like immediately, right? Because if it was a swap, you would see another label here, and then right before this 707, you would see another label if it was a true swap. So technically, it got a label pushed on it and then moved over, popped off, and then sent with the VPN label, service label, popped off. That has the next hop already in it, so it just moved it over. And that's technically why uh, I think I did this in the last video. It's faster with the VPN label because the next hop is already calculated in it, right? But that's option A in a nutshell. So the key thing you need to remember with option A is once you get to the ABR, it's a normal IP packet. It is not a labeled packet. When we talk about option B, option C, it will be a label, right? Between the ABRs, it will not turn into an IP packet. Now with option D, it will turn into a label. It will turn into an IP packet between the ABRs because that is the combination of B, and A. Right? So you get the control plane features of B, but the data plane separation of A. And that is probably one of the limitations of option A, why you don't see this as much. Now, we have 3 customers on each side. But as you can see, if I had 1,000 customers, I would have 1,000 VRFs on each ABR, which is just not scalable at all, right? Now, does this give you the better security in terms of like traffic separation? Yes, because technically they're all under their own separate VRF. But the likelihood of you implementing this in real life and having like from an administration standpoint, from a management standpoint, every customer you add is another VRF that you now have to configure everywhere, especially on your ABRs, right? So that's the headache of this. But it's faster and easier to configure this compared to the other two. Now, for me, I would say option B is a little bit faster because you don't have to worry about putting the VRFs at each and every link and having multiple sub interfaces for this. You can use one, um, so you don't really need that. But there is a command that you need to put in to allow certain routes to go in on option B, which I will be going over in the next video. So hope you enjoyed this lab video on inter AS L3VPNs using option A. If you did not understand this, please watch this video again and really go over the concepts, or at least the configurations that you saw. And then if you didn't watch the other video, remember I put a card in the beginning of this video to point to the theory of option A so that you understand why it looked like this at the end with the results when we configured it or when you saw the configurations. So this is Don from Padlock Technologies again. Got a question? You know it's going to be a video bumper at the end with the email address of where you can send your questions. Remember, I don't know everything, but I know a lot. And if I can answer it, I will create a video just like this one answering that question. Thank you and have a nice day.